All right, should be live. Uh, Welcome back. It's been a while. Had a busy week. But yeah, I'm back. So last time I think I was working on that crazy TTY bug that ended up in an interesting discussion on the kernel mailing list, and we ended up deciding that bit uh test and set bit functions in ARM64 have been broken for like 3 years. So that was fun. And yeah, the next thing that I have on my list of my laundry list of things to take care of, I was going to say this month, but it's going to end up going into September at this rate, um, is fixing USB on the Mac Studio and the iMac because they have a USB controller that is shipped without firmware, unlike that chip on every other machine, which has the firmware flash. On the Macs, it doesn't. And they Apple loaded off from the kernel. So there's going to be some some interesting stuff to do here. So let me get the screen up. Um, yeah. So one yak that I'm going to shave. I started already shaving actually while I was on traveling. Is that I want to make a proper PCIe device tracer base class that handles like the base address registers, because PCIe devices can be mapped to different addresses, so we don't know that in advance. The OS might just decide to do whatever. So I already started working on this. I think it's untested. So hopefully this will be a good start. And then I can reuse this for the Wi-Fi. There's also a whip Bluetooth tracer PR that doesn't have this functionality and just hard codes the addresses. So like I don't have to do this right now for USB because it's simple enough. I could just hard code it, but it should make life easier in the future. So might as well shave this yak. And then after that, the the interesting thing is like the firmware loading is actually pretty easy. So the interesting question is actually going to be, how do we do that in Linux? I know there's at least one other xHCI chip that has firmware loading support in Linux, but then I also need to write a firmware extractor um, for the installer, because that firmware is, of all places, embedded in the macOS kernel. So we have to pull it from there. Uh, so yeah, it's gonna be a bunch of random things. So I'm gonna be working on the Mac Studio for this. Hopefully it works. Hello. Yes. I think I have a regular Asahi and the original version that came with this, which should be 12.4. Um, so let's just switch to macOS. I don't think I have the hypervisor stuff set up here yet, so I'll have to do that. I think it should just boot macOS this time around. Yeah, it's just booting macOS. So let's shut down. Actually, what is my password first? Is it that? Yes. Um, yeah. So this is when I installed Asahi. So let's shut this down. Go and do our usual hypervisor mini override install. So I actually just updated mini and then pushed some changes that I had pending on the other work tree from the machine I was working on. So that should be fine. So that also means that since I'm installing this now, I can skip the chain load step before the hypervisor. Oh, and I think this has Lena's speed up changes, so it should be faster now. Yeah, it's shut down. That's just my capture card likes to keep the last frame it saw. So let's get this into 1TR. Let's get into options. And get that file copied over. Is it possible to run 1TR under the hypervisor? That is a good question. I don't know. I imagine so, but it's not going to be 1TR at that point. In other words, I expect the actual environment would work, but you wouldn't actually be able to, make boot policy changes because it wouldn't be 1TR at that point. Wouldn't be even recovery mode because that also has to be trusted. So, like, I imagine the environment would launch, but you wouldn't be able to make anything other than going back to full security policy changes. What I don't know is how to make it do that. Like, I imagine there has to be some kind of boot args that XNU gets. Probably also has to do with like the boot manifests and stuff in order to actually launch as 1TR, and I don't know what those are. So probably part of it is just thing the UUID of the boot volume, like the root file system volume to the recovery one, but there's also that RAM disk involved, so yeah, that would need some investigation. This is actually, I'm more interested, not so much 1TR, but the related thing with firmware updates I'm interested in, because we eventually do want to support system firmware upgrades from Linux, and I think Apple do that with a RAM disk. So I think it involves basically copying a RAM disk into the like pre-boot partition, and then like rebooting into macOS using that RAM disk to do the firmware upgrade. And so I want to see if those upgrades can happen inside the hypervisor, so I get a nice boot log and see what it's doing and understand how it works. And I think that doesn't need a trusted system because everything is signed anyway, but I'm not 100% sure. Uh, anyway. Oh yeah, it helps to plug in the Ethernet on this. There we go. Hopefully that will work. Maybe not yet. I think it's trying now. I remember it taking a while sometimes to start, and I wasn't sure why. Maybe it's just like ARP shenanigans. Oh wait, no, I know why. It's because I've right. Yeah, hold on. Um, yeah. There we go. And first I need to disable everything. Oh, what install is this? One is Asahi, and two is macOS. The order is like random on every boot, by the way. I don't know if it has to do with like the order APFS volumes are enumerated in or what, but all right. What was that? I was forgetting. Is it B or C? It's C. Okay, that should do that. And I think this is, I should have checked the version. I think this is 2.4. That was the one that the studio shipped with, right? Yeah, I think it was 2.4. Oh, was it 3? I'm confusing myself. No, maybe it is 3. Might be 3, yeah. Because 2.4 was the M2, right? Yeah. Okay, so we got that. Kill this. Proxy client, guest. Mac 13J. Oh wow, that is an old command line. I don't need the chain load. Is it 12.3.1? Is it 12.3.1 or 12.3? Might be 12.3.1. Let's try 12.3. I mean, I don't really care as long as it boots, but that didn't do anything. Wait, hold on. That's the wrong kernel. Mac 13J for starters. Okay, it gets somewhere. And the funny thing is, you get to see the boot progress bar at the beginning, which you don't normally, because iBoot doesn't initialize the display, but we do. So, and there's no Apple logo for that reason, right? Because iBoot doesn't even set up an Apple logo, and it's not like we're gonna ship the Apple logo. Maybe I should just have a thing where, like, if there is no Apple logo, it just leaves the Asahi logo in there. Because we can mini HV init. Yeah, so there's improved logo and shutdown, and maybe I should just like make it detect that the existing logo is blank, and then just not replace it. And if I'm not mistaken, yes, then you get the Asahi logo with with macOS booting, which is pretty hilarious. So maybe we should do that. If there's no Apple logo, just leave the Asahi logo on there. It's pretty funny. The Apple comes in when it initializes the display, though. But yeah, I think we should do that. Yeah, once it switches, you get the Apple one. So yeah, that works. Did Lena forget the TLB tracing in there? That's annoying. I think she forgot that. Yep, she put that in. Yeah, we don't need that. Was that the only change? Yeah. That should be configurable. Let's do a really quick thing for that. So TLB, it gets under init. And then yeah. Let's do that. Trace TLB OS, and then we can have trace TLB OS in here. Default to false, and yeah. Yeah, I was like I changed the tabs on that. Let's do that. Reminds me of Windows. Yeah, Windows does that, right? It puts down the spinner at the bottom and leaves the firmware logo up, I think. So it kind of is the same, yeah. And let me just stash whatever the hell this is, because I don't even know what. I think that was messing with hold on. We have that and MTP. I'm using. Hold on. Let me I'm just make a branch and. Yeah, I'll leave that there. So might as well stash it there. Now, this tracer. I don't think I ever actually started running it, so let's try that. I started running that like while I was in a car, and I don't think I ever tested it. So let's make a trace xHCI.py. Actually, let's call it trace as media because it's gonna be specifically that. Not experiments, sorry. HV trace. I do have a trace xHCI. Was that hard coded from before, or what was that? Oh, yeah, that was just hard coded, and it was just getting the whole thing. So we're gonna let's move that to trace as media, and I just edit that one. Close that. So this is the old thing with the hard coded address. I think. Let's yeah, take that. From mini trace, import PCIe, and then we can do a PCIe dev tracer, and we need HV port path, which is what in here? ADT SM Studio, yeah, I think it's M1 Studio.txt, yes. APCIe. Oh, right, and this has like. All right, they only use APCIe ports on die 0 on this one, I think. Yeah, because they have C's. 2, 3, and then like 4 is the one that's in the second die. Yeah. Yeah, but they don't have the. Okay, so they don't use the PCIe on the second die at all because none of it has addresses here. Which makes my life a little bit easier. So let's just sock APCIe. Sorry, ARM IO APCIe, and then I need the port for this. Where was USB in here? LAN is on PCI bridge 2. xHCI is in PCI bridge 3. And 0 is what? Wi-Fi. And 1 is what? SD card reader. Okay. So this should be bridge 3. I think that's how I was intending this to work. Port path. Yeah, and then we need the bus dev and function, which we don't have. The bus is 3. I think the device is just. Wait, am I right? The bus. I don't remember. I think the bus is the port. Or maybe not. Well, I'll find out. I can just trace the entire eCam anyway. Yeah, let's just do that for now. And I'll get this pretty easily anyway. Let's see what that does. Guest, and then I can get -m HV trace as media. Try that. Of course, yeah, this doesn't even build. Like, I didn't even ran this. If not size contain... That doesn't make any sense. Trace bar, index bar, max, return. Yeah, you can tell I never tested this. From mini trace, import star. Run script trace as media, just write like that. Okay, def path. It's port path, not def path. Ugh. Wrong button. Oh, right, and this doesn't reload. I think those are reloadable. Anyway. Okay. No attribute reg maps. Isn't it bar maps? Right, because that's the reload class thing. It was called bar maps. And now that's not going to like the reload. Let's reboot again. I got multiple values for argument verbose. Is it just because Tracer only had verbose in it? Yeah, that's why. There's no port path there. And now def path. Okay, now we're missing a reg. Because it's the parent on that. But then why am I passing the port? Oh, because translate... Wait, is translate in the port? I think it was. Hold on. The ranges are in the parent. And the bridges... The bridges don't have ranges. So that doesn't actually matter. Wait, do they have a null ranges, at least? Doesn't look like it. But I think I need to fix that anyway. Reg... Yeah. Do I have a parent in here that I can use? No. Okay, let's call this a PCIe and actually just do it like that. And int object has type. What? Oh no, trace reg map. Get the arguments to that wrong. Start size class mode name prefix. Yeah, reg map. Var maps index. Oh, it should just... Oh yeah, I do need to subclass this anyway, but... doesn't matter for now because it's empty, but int object has no attribute name. Oh, the ecam. I'm doing this wrong. Yeah, why am I passing self? That doesn't make any sense. Okay, now that at least runs. And then I'm going to need something for the bar maps. But for now, let's... yeah, let's just do a full trace. See what happens. Yeah, okay. R bar, no attribute address. At base is what that's called. Bar. Where is that? Bars index. Base, yeah. Right. Sure. Says new attribute update bars. It's update tracers. Okay, and then our bar int. State bars i+1 dot base dot addr dot base. Sorry. Oh wait, no. Then I actually need the whole value because this is really the whole thing. Val. You. Yes. Okay. And now what? List index out of range. Oh, because that's all Fs. Is it because that's a right? Yeah, then I don't really want to... I really just want to read it at that point. This does mean I got the device right because it's actually tracing it. So self why am I even keeping state here? I can just read it whenever I update the tracers. I mean, I could use like when it reads if the state's FF, then that's the size check. And then when it writes the bar update tracers, yeah, it should just read them back here. So instead of self state bars, it should just be actually, I don't even remember how the tracer set up the reg maps. Trace reg map. Yeah, I just want to initialize this. Let's just create it. Yeah, let's just reinstantiate that, and this needs to be... I think we just pass you to this. I forgot how to use reg maps. And then we can just use config space instead of that. And get bar I. And I plus 1 for this one. Reg accessor has no attribute base. Dot reg. Okay, that did something. And that's the firmware related stuff, I think. But it's not tracing the bar. It's that's only the config space because those are the offsets. And why did it just die? Oh, that's weird. Oh, I know why. Because we tried doing this in a async context or something. I need to fix that so it just like doesn't let you do that. But what happened here exactly? Yeah, trace PCIe. I tried to get the register from a handler. Yeah, this needs to be, what is it by default? Default says trace async. Yeah, this needs to be sync. Trace reg map. Mode, yeah. That needs to be sync, and now this is going to be broken. From trace mode. Yeah, okay, that's going to be very broken now. Because if I'm tracing asynchronously, I can't actually like read registers. Because like that guest is still running and yeah, everything breaks. I need to somehow make it just refuse, like fail operations with an exception if you try to do that instead of exploding. Okay. Reg accessor has no attribute value. Is it val? Looks like it. Ah, I forgot about the start. I also need to fix that. Let's do. That has been annoying me since forever. In run guest, many tools run guest. Yeah, it runs a shell. Yeah, why? Just do it like that. I don't know why I made it that way originally. It doesn't make any sense. Because normally when you are in a shell later, Control D is how you like resume. So, and like if you exit at that point, you can't come back because it's already half initialized and everything explodes. Okay. So it's still not tracing the right thing, but that's because bar maps is empty, so it wouldn't actually trace it. However, oh yeah, you can see like other bar stuff happening there. So let's go back to the beginning of that. Yeah, so there's, let's see. I should just log these. Bar. So you can run that, and that should actually just... Yeah, there we go. You can see it there. Ooh, what happened? Okay, that's wrong. That's... Huh? Oh, because of the... Yeah, because translate... No, but translate shouldn't... Okay, my translate function is apparently broken. Because... Yeah, that's normal, but it should actually... Oh, is it because it's not? It doesn't match any of the translations. Ooh, that's weird. Is it just because they're unused? Let me look at the device tree again. So we have these ranges. 43A05, parent address is 5A, and then 5C. Wait, that's not enough. So wait, is it in the ports actually? Or did they just like break this? I thought we had ranges that actually made sense in these things. Or is this correct? This might actually be correct. And we're looking for the 2, so this one. Bus address 2C0, parent address 5C. Yeah, okay, so it is right. Yeah, so that C100 though, that doesn't look... Also, size is -1? That's not right. Oh, because bar size... Um... Oh, okay, so bar 0 is right. But then somehow the addresses are wrong. So what are the registers right now? Big space. I have a dump on that. Show. Print. I thought we had a thing to dump like whole reg maps. Dump regs. Okay, so bar 0 is not configured yet. Is there any progress? Meals use the Thunderbolt ports to the Mac Studio to connect the monitor. Sven is working on that. Okay, so what exactly got written? I should just log these for starters. Phase, verbose, MIO, regmap, yes. Um, So this one should be... For starters, it looks like the wrong address. Am I even in the right device? What is vid? Isn't this different? Oh, that's Apple. That's not right. That's like the root port. So I did not get the device right. And actually, this is writing to 10E2 a PCIe 0. That would be device what? Is it that they use like a different bus mapping than what we use on Linux? It could be. Actually, that would be like device 2 or something, I think. Because that's bit... Bus is 20. That is 20. So it's bus 1, device 0, apparently. R2 size is unknown. Yeah, because the ident changed. Let's dump it. Still has bar 0 MT. But at least 4 looks reasonable. Wait, it's the same values as before. No, that's not right. Oh, duh. Need to add the ecam offset. Aha, okay, now we have a bar 0. Yes, this is right. And I'm pretty sure this is the S media controller. I remember the 2042 thing. So this is a 64-bit bar. We just don't have the size for bar 0. If I reboot, it should get that. That's interesting, though. Why is it buzz 1? Because this is in bridge 3? So it's port 3? Does Apple just like dynamically assign the buses or something? Could be. Oh, interesting, and it has like the companion port specified here. And then the USB-C. Yeah, that's going to be an interesting story too, because No, it should be the same. And maybe Linux can handle this automatically, I'm not sure. Maybe it needs to be specified somehow. That'll be a different... Oh, bus number 8? But it's bus 1. And then there's no bus number in this one. And then this 0 just has port 0. This one says PCIe port 3. Yeah. Okay, I don't know why it ends up in bus 1. It might just be dynamically assigned. That's probably just what it is. And so then I guess we just have to, because that would be assigned at the root port level, and that's kind of going too far in the tracing. So I think you can see that in macOS anyway. They're probably in the system info. You can see what the PCI devices are. Anyway, this is good enough for now. Let's just reboot, and then and the trick is for this particular device, I also need a config map, which is PCI config space. So I need to actually use the class for that. Yeah, and then we can just use that. So I need to do a as media config space reg map. Based on PCI config space. And then we add at least that funky, well, let's see what else is in there, because I know E2 now is this is the address for the ROM writes, but there's more. And then I need to filter out junk, because there's a lot of junk. 7, 6, 5, 4, 3, 2, 1. At the beginning, there's going to be some stuff, probably. Yeah, so E2 is something, EF is something, E0 is something. Yeah, there's a lot of things that happened there. So I think these are the standard ones, like 1 for whatever. And I think starting at E0 is when you get the funky proprietary registers. So let's just make some unknown registers for, and that one's apparently register 8. F8 is 32. FC is also 32. And then we have F0, F4, which are also 32 bits. And then apparently this thing reads them byte by byte. That doesn't make a lot of sense. That's weird. And it gets like different values from what I had before. Is it because it wrote that E0 to 1? Probably. Then we have EF, and that's another byte. And then E2 is a word, and that's the address. Yeah, because like my regmap stuff doesn't really support accessing the same registers and multiple widths, because you're normally not supposed to do that. So I'm not sure what I'm going to do about that. Yeah, and then we need the bar. I think as long as it's set to verbose 3, we can do a trace reg map. It's a reg map. If reg is not none, yeah, look up address. It'll return none if it's verbose 1, and then it'll just print it. Yeah, as long as we have verbose 3, even if this is empty, it should print everything. So I can just go make this as media bar 0 reg map. Just pass, and we should see some stuff there. Let's reboot, see if that does the right thing. Oh, and then we need to put this in bar maps. I think I'm seeing stuff there. Yeah. Okay, stop that. Yeah, so ROM address 0, and then it's... that's different, sorry. No, that's not right. Why is this not printing the register? It should be printing the E2. Why is it not doing that? Oh, because I didn't set the config space. Ah. Okay, and do that again. It should keep things. No, it still doesn't work. Under trace, reg is none, address equals value. Why? If I do get name, that doesn't work. Oh. Why? Why is it not using that? Run script? Oh. What now? It's inheriting from that. Why? Oh, is that one of those reload doesn't work things? It has bar. But I mean, is inheritance broken for registers? I thought that was working. Base reg map. I get some meta class. I guess this is kind of broken then. I don't know if the reloads are going to work here, but Actually, I can just let's just do it with a regular thing. Let's just do like take the setup stuff. Just import this and try it here. Yeah, clearly, clearly something is broken about inherit. I thought that worked. Like map meta, dict items. Case. Oh yeah. No, it gets bar. And then accessors. Oh, just the accessors are And then this looks at name map. Yeah, that's in there. And so then the accessors. Huh. Why is name map like incomplete? Kind of confused. The meta class is getting the right stuff, but then. Oh, because this runs separately for every. Ah. Is that it? Ah, that's why. Right. So then we need to only initialize these. Aha. Yes. Okay. Now it works. Meta programming is hard. Okay, let's fix that. Okay, and now we can run the cast and that should work. There we go. Now it's getting the right register there. But it's not tracing the bars properly yet. Why? Yeah, so you can see it doing things that... Wait, why am I getting a Dart trace happening now? I don't think I... What? Where Dart come from? I don't think I have the Dart anywhere. Oh, is it just because the tracer looks for darts? No. That those aren't. That's the wrong map. Am I like now overwriting different? Oh, because ah, yeah. Okay, I see what happened there. Right. Because otherwise, the base class is going to have that. And yeah, okay. Uh, can I clone a range map? I don't know if I can clone a range map. I think I need to add that. Start and value. I don't think I ever mutate values. Just gets lookup, replace, yeah, compact. Values. Ooh, this one might be tricky. The dict range map. How does splitting ranges work? That might be buggy. Oh, it does use copy, which is probably fine then. So then as long as I do it like that, that should work. Uh, let's try that again. As I said, metaprogramming is hard. Okay. That's more like it. Okay, command vendor ID reads. Yeah. Some of the lengths are weird because PCIe, but okay. So now it's writing. Why is it not getting? No, that's 3D. Those are fine. Yeah, there we go. So what about actually tracing? Why is it not tracing those bars when they get set, which should be around here at the top somewhere? The bars are at 10. I thought I saw some of those. Yeah, there we go. That's 10. Why? Oh, that's the wrong bus. This one's the right bus. Oh, interesting. That didn't work. So now arrays are broken, apparently. Or maybe they always were. Let me use that little test thing again. Where's that? Reg map. Get name. Oh, because it... No, it should be there. Sorry. 10 and 30. Yeah, okay. Arrays are broken. Yay! Yes, the reloading stuff is kind of flaky. It works well, like, in the steady state to some extent, depending on what you're doing, but it's not the best. I mean, it works particularly well when you do, like, the reload me thing, to just live reload a single class when you change the method or something. That works really well. But if you have dependencies, it's not the best. Well, this is not a reloading problem right now. This is a reg maps are broken problem. Why? Class method, lookup offset. Address map and range map. I think I messed up range map. Did I just say none? No, set range map. Yeah, okay, so I probably broke clone. Wait, did I actually clone it? Did I forget to actually call clone? I think I forgot to actually call clone, didn't I? Yeah, duh. Oh, and then I forgot to return it. Oh, and then this is not range map. This is that. Yes. Okay. Let's try running that again. Be careful with non-zero returning false and if x versus if x is none. I think self-start bool should be the right thing there. Non-zero is just when the length is not zero, so I think that should be fine. Big fan would like to ask, can you suggest an online resource so one can learn to do what you're doing? Everyone asks a question, and I don't know what to answer, because there's not, like, any single one thing. Like, it just depends on what you want to do exactly, right? Like, what kind of platform or whatever you're trying to target, and then there's going to be different resources for that kind of thing. But there's no, like, single one that I could point at. Okay, ROM address 0. Where'd my bars go? Here we go. Okay, now we have the bars, and that gets written. It's red. Sorry. So when they get written is where? That's one right. Yeah, okay, there's a tracer there at 5901. That does look good. plus print tracer. But that's not the right address though. Oh no, that's just the bar getting retraced. That's not also, what am I printing? I'm printing something there. I forgot to print somewhere. Yeah, that. Oh, Jay says, I'm taking the train now. Good luck. Maybe I'll join the other side if you're still streaming. Yeah, I think I'll be here for a few hours, so. What is going on here? The gets written, but there's no. Trace bar. Oh, because we need prefixes. That's why. No, we don't. Uh. Also, why is there a tab there? Okay, hold on. Okay, it does get called, doesn't actually trace it. Why? Didn't I set bar maps? Yeah, it's in there. It gets called. It claims to be tracing bar 0, but 5C, you know, it's there. Oh, now it's showing up. Wait, was it not showing up before? Oh, interesting. Okay, so what the update didn't get called when the bar was written, or something weird happened. Yeah, so we can see that 3010 is like SRAM data or something like that. So might as well add that one here now. And it's so weird that the address is in the config space and the data is in the bar. This thing is weird. Okay, so how did the bar not get read? Right, bar 0, C0. Okay. At this point, why didn't it actually trace bar? Is it just because I reloaded and fixed it afterwards? Yeah, so this is the size stuff, right? You can see that when it does the 0, yeah, so you can see that. Should print that in. Yeah, so the size calculation stuff is fine. And then somehow somehow that write didn't actually trigger the. Maybe this was just broken. Oh no, it's because the write. It's because this happens before it commits. Because I'm in sync mode. That's why. That's why. That's why. Um, right. That's why. Because it. Yeah. Um, yeah. So then I can just say, uh, I guess I could just read this from the state in practice, because that is already getting updated by that. But if I equals index, no, it doesn't make any sense. If I plus 1 equals index, then bar h is val. Else. Val 32. Yeah, that should do it. It's a bit hacky, but let's give that a shot. That. Our bar has no attribute val because it's value, isn't it? Wait. Uh, right. Just need to do dot reg and then get dot value. Yes. Index out of range. Oh, because that ended up there. Okay, that still didn't trace. No, yes, it did. It's from data. We got it. Okay. Okay, let's do another reboot. Get rid of the trace device to get only the get rid of the spam, and hopefully that will be a clean log. Also, I'm gonna log this. Okay, that is yes. Let's let it actually load the entire firmware so I can look at the full log and see how it ends, because there's probably going to be stuff at the end. And since this is in sync mode, it's also very slow now. No, wait, only the config space stuff is in sync mode. But it's the problem is that it's annoying to get only part of it in sync mode. So yeah. That's also why CPU one shows up there and only some of them. Because I think only the sync mode stuff ends up doing that. However, one thing I can do is switch this to W sync mode, and that'll be a bit faster. Slow. Also, why is it doing like... Yeah, okay, it does do this from data. Yeah, so now you can see the sync one is only the writes to the address. Ah, okay. And now that's just xHCI stuff, I think, that is happening now. Still booting. I think this is just normal xHCI stuff. No, wait, there's still SRAM data and... Oh, and there's other stuff going on at the same time? Okay, that's weird. What's up with that? Oh, it's like... Oh, it's reading. It's reading. Okay, it's... It's some kind of readback operation. I guess you write to the data register once. This is so. The thing is, you can tell like this is some kind of This is some kind of like debug feature in the chip that they are abusing to By the way, does this even work with full addresses? Because that's the other thing is like it reading bytes for no reason. Yeah, it doesn't need to be bytes. Why are they reading it byte by byte? That doesn't make any sense. Okay, now and that's xHCI finally. Yeah. And so now if I plug in, I don't know what, should I plug in? I have a flash drive somewhere. Oh, there's an Ethernet adapter here. That'll work. We should get some activity. Nope. Oh. Helps if I plug it to the actual Mac Studio. Yeah, there you go. Oh, wait, SRAMs again? Is it resetting? Oh, get firmware version? Okay, that's weird. Is it because it like suspended it or something like that for power saving reasons? No, it's reloading the firm. Okay, what Apple? What are you doing? Maybe it like suspends the chip and turns it off. Because there's also an SMC event there. Is that like a hot plug? GPIO2, is that listed in the device tree for something? Oh, that interrupt is... I don't know what that is, but it might be the SMC. Interrupt parent 218? Oh, that's SMC, all right, yeah. Event name... Oh, USB 3, there's an event for that. Bit 9. USB 2 plug, USB 2 wake. Yeah, I don't know how the mapping works here, but I bet that's what's going on. Yeah, okay, now it loaded. Forcing a hardware exception. Okay. So yeah, it also like reset it for some reason. If I unplug it, yeah, it enables some vector thing. Destroying, connect, change, interrupt. And it did a bunch of like core reads, then wrote 7C. That might be a power state thing. Yeah. Yep, I think it like powers it down to save power, which is the stupidest thing because this chip is only used on desktops. How much power are you going to save on a desktop by turning off the USB controller? This doesn't make any sense. I mean, it's cute and everything, but why? Okay, I'm tired of this. I have enough of a log. Yeah, so let's look for bar. After that, yeah, it does it. That's when yeah, next time. Another interrupt. I'm not sure if it's power saving, but that SMC interrupt being involved is kind of because they can't really reset the whole controller if you plug in something because there's more than one port. Yeah, so there's other registers involved there. It's waiting for that to become 0, then write something. Yeah. Isn't that like the xHCI port state stuff? And we're back at looking at USB specs. So at 20, that should be the command register. And so what that did is it's waiting for the HC reset. It writes a 1, and then it's supposed to come back. So does it actually write it? It's writing to the what? Or am I getting the offsets wrong? What? You can't write to the... Oh, no, it's 3000. Sorry. These are the... Not, yeah. These are custom. Okay, let's add some tracers here. So that's a 16-bit, and then we have 9 and 4, which are bytes, apparently. And then we have the USB stuff. So the 20 would be... And that one is 32, yeah. I'm not going to bother with the bits for that because I get that too. That's the only thing that matters. But okay, so when it starts, So the very first time after... Yeah, so this is how it all starts. It sets up the bar. I think everything here is standard. I think. Yeah, then it reads the bars again. Okay, and that was getting interesting. The first thing it does is reads E0, writes this to F8. Writes that to FC, writes one to E0, reads that back, writes 4 to F8, FC, sorry, zeros. You know, this might be like a write memory command, like address data command to write the one there. And then it writes 2 to E0, reads 1, so that it looks like it waits for that bit to be clear. So E0 is like busy or something like that. Oh, look, it reads a 3 in that case. Oh, that's interesting. So it's like status. And E0 gets a 1. And then it reads a 3 again. Yeah, I don't know what E0 is supposed to be in this context. But look, F0, F4, it gets back what it wrote to F8, FC. It's a bit like read data and write data. So maybe 2 is like write. No, but then there's another 2 there with zeros. I'll have to mess around with like a mon on this to see exactly what it's doing. And then it reads F0 and 1, 2, 3. Okay, so this is like reading back some data. 5, 9, 8, 16, whatever that is. 15, 9, 0, yeah. And then it gets a bit more, 2, 1. Yeah, so it reads like 6 bytes. So it does look like some kind of command like interface of some sort. Oh, is this like a FIFO? Maybe 2 here is like push. and it pushes these two words, and then it's like pushing 0. So this is like writing 4 words, and then the maybe that bit gets cleared. So it's like it waits for that to be cleared, and then in this case somehow it didn't get cleared, but it also has some read data, which is bit 1, and so then writing 1 is like pop, reads again, and then it reads those bytes, and it writes the 1 again. Oh, but this is interesting though. Oh, no, it isn't. Yeah, yeah. So maybe that's what it is. Maybe it's a FIFO. That kind of makes sense. That this is like a debug FIFO or something like that. And then after that, so presumably this enables some kind of debug mode that gives direct access to the SRAM from software or something. And then after that, it writes some magic to 3000. 5042, reads back 9, then writes that. And then it waits for a reset to complete, which it didn't actually initiate. So this is, I guess, some kind of reset function. Does that make sense as 542? No, it doesn't. So maybe that's some kind of internal register that also includes the reset thing. And then it writes 5000E, whatever that is. Yeah, I have to mess with this with Mini and like Linux running or something and see what's going on. So then it writes that bit in EF, which this might actually be the like SRAM access enable bit. I get the feeling this is going to be set to 0 at the... Oh, to C0 apparently. Yeah, so after it finishes writing... yeah, then it's... Oh, interesting. So then it's in like read mode. Then it sets... Yeah, so this is like read mode then. And then it's setting the address... I don't know why it reads everything back every time it writes. Is that just because of PCIe posted writes? No, but config space is not posted. That doesn't make any sense. And it's not even reading back the data, so I don't know what's up with that. Which that's the one that is in in bar space. And then SRAM address just keeps getting oh, interesting. Okay, so it writes 0, reads 0, writes like a flag to the data, reads back 2 on the address. So maybe it auto increments. And then it's just reading back the whole thing. Interestingly, in units of 2 words, even though before it was writing in units of 1 word, so I'm not sure what's up with that. And then, as I thought, yeah, it becomes 0 at the end. So when it finishes writing, it sends that other command, the 5040 thing, and disables whatever that is. Then does 5000E, waits for the host controller to reset again, and then it's checking status, HC halted. Which is expected to be 1 at this point. Then there's some PCIe nonsense, and I think at this point the regular xHCI driver is taking over and just driving this as normal. Because it writes a reset. Now it's writing a reset command, a regular one, and then it's doing the port stuff, and then eventually it writes D, which is run stop equals 1. It reads that back. It reads halted, and then it becomes 0. So this, by the way, is where Linux gets stuck. Without firmware, it never actually starts. I remember that from the last time I looked at this. Okay. Just one sec. Going to... I'll be right back in a sec. All right, back. Okay, so here's the plan. I'm going to be running Linux on this, and even before doing anything in the kernel, because we don't have a good PCI bringer code in Mini, so we can't actually run Mini scripts to test this. And I should do that someday, but I'm not going to shave that particular yak right now. So what I'm going to do is I'm going to boot Linux, let it try to initialize the PCIe controller, and use the tracer to find out when it does that. And there's like a longish timeout for init. And so I'm going to just stop it there and try running some scripts that I will cook up in Mini to load the firmware like this. And if I pull it off right, I should be able to like load the firmware, then initiate a host controller reset, and if the operational registers that Linux said did not get reset, it might actually just kick the controller into life, and then Linux like picks it up and it works. It's kind of horrible, but I'm gonna try that. If it doesn't work with Linux anyway, it doesn't matter as long as as long as from the script that I write, I can tell that the host controller is becoming operational. That's all that really matters anyway. And then I can just move the code into Linux. But the first thing I need to do is extract the firmware. And I know that's in the freaking XNU binary. And further, I know that that is in a weird interleaved format. I remember I pulled this out once already. Is it in bins? I had this somewhere, but I don't know where this is. Maybe not. Vendor bin. Either way, it's I know the kernel has it. So let's just go into kernel tests and look at that existing kernel. This should be 12.3. And then I need to make. Is that init bin? No, I don't think that's it. And then I need to make an extractor for this, which is going to be a pain in the ass. Yeah, so at least I can. I think there are some strings in the firmware. Oh, sorry, .mako. This is compressed. That's not going to be very useful. I think it might be one of these. So we should be able to see the beginning of the firmware somewhere here. No, that's still macOS, but it's somewhere close to this text stuff. Or not. I can look at the text. I have the texts. Yeah, I think it's this one. Yeah. Let's get 12.3. Oh, don't have that. Oh, sorry. It's under extensions on this one. Take the V out. That looks like, let's see, this starts with 01027588. I know it was weirdly interleaved. I think this is ARM code. And I don't know what that was. I think those are something else. Oh, this might be it. Ah. I thought there were strings in the firmware, though, so... Oh, this might be it, actually. Maybe this is the weird interleaving. No, it doesn't look like it. Or maybe it is? Oh, 225. No, that's not it. Does this relate to getting xHCI working on the USB ports on the Mac Mini? xHCI already works fine on the USB-C ports on the Mac Mini. You might be thinking of USB 3.0, which is not an xHCI problem, it's a PHY problem, and Sven is working on that. It has to be this part. I mean, this looks like what I would expect the firmware to look like. Unless it's just a different version. No, I am on the same version. This is 12.3. And there's some zeros at the beginning, and it's like writing in parallel. So it's like 1, 2, 2, 2, 5, 5, 1, 5D, and then zeros. Let's just search for 75. Oh, look, 7588. 1, 2. Yeah, this has to be it. Am I just using the wrong version? $50.82. That doesn't look right. This is the right version, right? 12.3? Yeah, 12.3. Unless it's a different one. It should be that one. Or not? Hold on. Maybe I'm just in the wrong one. Ah, there we go. Here's the firmware. 22148 firmware. Okay. Wrong file. I think I was reading x86 code on the other one. Okay, so somewhere at the top of this is where. Okay, look. 0102 0225. That's part of it. 102 225 515D, and then some zeros. And then there's a 287 CD. Yep, that's it. Weird that it starts like off there in the middle. Like there's a header. I guess maybe there is a binary format involved here, which might be convenient for searching for this in the kernel image. Maybe we can make this like fully generic. So is that firmware thing actually getting uploaded to? You get zeros, then more. How many zeros there? Oh, quite a few, yeah. And then it starts 1911. Yeah, yeah, that's right. Okay, so it really is just this blob, and then the top bits are like the second half because of the weird interleaving that's going on. And I think everything else is just contiguous at that point. And it should stop there-ish. So what does it do at the end? Yeah, so the read backend's there. This is getting zeros. All right, that is interleaved, so it's going to be weird. Yeah, and there's a lot of padding at the end, too. So this looks like this is some kind of binary format, probably that like as media's tooling generates. So let's use a hex editor to pull this out for now. The nice thing is there's that little tag at the top, so we can search for that. So we have that. And then the actual data begins at 102, so here. Oh, 102, 0225, 515D, yep. So interesting that there's like an odd number of bytes of header there. Is there any offset for that? There's a 30 there. That's not quite right. None of this has to do with the other stuff that gets written, right? The 5042 and all that? I don't think so. What about before that? 6840. Doesn't look like it. Let's see if there's any obvious like length or something. Let's go to the end. Yes, that config stuff at the end, and then some padding, and then that weird like second block. Some more interesting things there. Does the person fixing USB 3 on VC have a Patreon? Nope. Sven does actually have a full-time job doing other stuff. So I think he decided that he doesn't need that. Okay, I think this is no longer firmware. Yeah, I don't think that's firmware anymore. So I think it just ends in zeros. Possibly there. Oh yeah, and that's a size that looks about right. Okay, let me just grep for SRAM data and do a few lookups in here. Wait, 4, sorry. Yeah, so the second chunk ends on there with some FFs and then an A00. That's not right. A lot of Fs there. Where's the Fs? Oh, there's Fs. Okay, that's sort of the second chunk. Second chunk? Is that really where the firmware ends? Oh, is this something else? No, that's still in there. Oh no, that is more second chunk. It's just that there's zeros. Okay, so when does the first chunk end? First, let's go to the beginning, get this aligned to something reasonable because the lengths are going to be useful. So 102 starts here. And then 7588 as hex. Huh? That's not the right offset. That's it. Yeah. See how this is at 8,000. So this is interleaved, right? 8875, 5082. Yep. So the first like 32K and the second 32K are written at the same time. But there's not much left after that. Yeah, see, it stops there. Which means I think this is unrelated at that point. Yeah, it's C00, I think, is the length of the firmware. I think this is... What is that, actually? Oh, no, there's more, though. Because then there's EF74s coming in. Oh, okay, that next part. Um, okay, so there is more second half. And then... that keeps going until... 79FC-ish? No? EF74... Ah, there we go. 79FC. That's a few zeros. So then this is something else, maybe? Because then it's still reading the beginning. Yeah, so then that should be ending pretty soon. And then what's the next part? Because if those two blocks are interleaved, this next block, is that also interleaved? 74F2? Ah, yes, and then 812. Okay, so there's another block there. And then that has zeros. And then at 8,000, ooh, there's more. Okay, I think that's actually not written anymore. There shouldn't be any high bytes after that. Yes, zeros. And it ends. Yep. So there's two blocks interleaved and then one more block that is not interleaved. When is PSA planned? After this. And I need to fix Wi-Fi sleep and then get to that. Okay, so now we know what order things are written in. Now this header, I would like to see if there is some useful header here I can use or not. Are there any lengths worth speaking of? That looks like a length, a 180 that looks like a length, and then the firmware starts. Yeah. That 30 could be the offset to the firmware part. I don't know about that MK thing, though. Maybe K is a tag. Maybe this is like a tag length value thing. And the other things are probably checksums, which we don't care about. Okay, do we need a header for this? We probably don't need a header for this. We can just have the raw blob. Really curious to see PSA with 3003 and see how to do the amazing process and suspending this huge socket. The thing is, you don't have to suspend the whole thing anyway. Like the most important part is actually just putting the cores, the CPU cores, into deep sleep, which we know how to do. It's easy. It's just that we don't want to put that code in Linux, so it'll go in PCI. But once that's done, like I bet you'll already get like ridiculously good runtime. um, and then it's just suspending more devices. But some of that already works. So okay, so yeah, I think in this case we can pretty much just extract the firmware, and we should probably have like a SHA-1 or something to verify it. But I think we can, or even just check the lengths and stuff. Okay, so in this case, let's go to kernel tests 12.3. Just grep for that even. Should find it. And it should be in all of them. All the macros. Yeah, well. Yeah, that looks about right. Actually, I have a big grep I can use. 2214A RCFG is 32323134. Can't I copy the hex in here? Like, copy as. Huh? Yeah, right. Yes. Why isn't it copy as hex? That would be a lot more understandable. Oh, there's two of them. Well, that's interesting. Oh, there's oh, like one of them is like some kind of I bet something else. Let's go to that. Mm. Yeah, so that's the real one. And then the other one is what exactly? That might be part of the firmware. Yeah, that's part of the firmware. Um, so how do I find the first one? Well, it's always going to be the first one by order if I search for it. But I can also look for 10 after that. And oh, 1002, that's the device ID, isn't it? Is it? Um, mm -mm. No, it's not. Or is it? Is that like the... Oh, is that the subsystem ID? No, it's not. Okay, so that's fine. Now, the next problem we have is that the kernel is compressed, and we need to uncompress it. So I do have an image for like PE extractor, but not the BVX2 uncompressor in Python. So we're gonna need some, and obviously we're gonna do that in Python. It will take forever. So we could ship image for tool, but that kind of sucks. I wonder if there's something in macOS we can use for this. Oh, but we need to do it on Linux too, so that doesn't help. So we might end up having to make a Python module for this. So there is a library in macOS for this, which we might be able to just like see types and avoid having to build funny stuff. Hopefully this isn't recovery mode. You'd think it is. So is this packaged for like Arch Linux and stuff? It's an AUR. So we might have to just ship that package. Oh god, is this like also gonna be Objective-C or something? Swift Objective-C. This looks like a C API. Yeah, this is a C API. That's good. So I might be able to just C types this and make it work on macOS that way. And then on Linux we can just ship this. Does it use the same headers or is it different? No, it's gonna be different. Yeah, it's just decode buffer. But at least it's easy, so I don't mind supporting two APIs for this. Okay, let's implement first the Linux version. Do I have this in Gen 2? That's not Gen 2. Might not. Nope. Also, this is like an ancient thing. Did I have this in Asahi software? Yes. Yeah, so I guess we just How big is it? Yeah, it has enough files. Um, okay, so let's try that. Let's try building something that will work on Mac OS and on Linux. Um, on Linux, we ship this. On Mac OS, recovery mode has to have this, right? I mean, it has to. Like stuff has in recovery mode, stuff has to be using this. Um, yeah, it's this compression.framework. Hold on, I'm just gonna check real quick on my like MacBook and get it in recovery mode. I won't show that, but just I'm. Where even is compression.framework? There's a compression text. Is this like not a framework, or is it just because it's only in the cache? But I have Xcode installed here, so also why is this an accelerate? Is that what? Is that where it is? Is that where it is? And what is it? Is that where it is? No, that doesn't look right. Where is this? I'm like really confused now. Like, where is even the what's the include? Why are Apple's docs so bad? It's like, here's a framework. Okay, where's the header file for this? Why are you giving me chunks of a header file and not telling me what the header file is? Compression.h in lowercase. Is that it? Actually, oh, there is a compression tool. In user bin. I wonder if that exists in recur. I bet it doesn't. Um, okay, so there's a compression.h in. Ooh, Python 3 framework has an underscore compression module. No, this is not the macOS compression. This is something else. Um, okay, yeah. So Xcode has oh, but compression tool might actually be part of yeah. There's a lib compression dilib and stuff. Oh, is it just user lib compression? But then it's probably just not there because it's in the shared cache. That means I should be able to just like import it on macOS. I know you can only, yeah, because I'm on a laptop, sorry, and I'm just checking to see what is up on macOS. Um, because it wasn't supposed to take this long to find the compression library. Um, let's see, just give me a second. Let's see how I want to do this. So compression tool is there. Maybe just the man pages come with Xcode. Because I don't think I have Xcode installed here on this. No, I don't think so. Just check. Yeah, I don't. Okay, so compression tool is there, which means I can just call that. And then I don't need to do any weird Python bindings. Now the question is, do we have that in recovery mode? Probably not. So let me do that real quick in 1TR. Hello, why aren't you? There we go. So yeah, sorry that I can't show you this. It's just I'm just on a laptop. Uh, it'll just take a second to find whether the tool is there, and if it's not, I guess we need to use C types for this. Yeah, no compression tool. Okay, so I'm just going to reboot, and I think this has the command line tools installed, but not full Xcode. That should be enough for trying this out and seeing if well, we don't even need the Xcode. I just need the header file. So hopefully that should be enough, and I can try making a Python script that works on both Linux and macOS. Okay, let's do that. Packaging this is going to suck because now I need to start compiling things. Well, thankfully I don't have to compile from macOS. So in the installer it doesn't matter. But then on the Linux side we need to build LZFSC. Okay, so in build I already have the library here. I can just use that with an LD library path or something. Git Asahi installer. Let me make sure this is actually up to date. Firmware, where is this? Asahi firmware. Okay. Let's grab because there's going to be multiple firmwares pulled out of kernels, and I obviously only want to decompress it once. Let's have a kernel.py, and then on top of that, once you have like the buffer, we can have a as media.py. So in theory, I can do Asahi firmware. I thought I had that. Dot core was it? Dot update. Yeah. And then I need to extract the Asahi get firmware, was it? Asahi vendor firmware. But this doesn't have the full tarball. Also, that should have been using better metavars. Yeah, because I need one. Do I have this anywhere? I don't. Let me just copy this out of. I think I have it here. Yes. GLAN boot Asahi all firmware .tar gz I think is what it's called. Yes. Endor FW. And just move it there. Git Asahi installer, all firmware. No. Okay, untar that. Firmware and FUT firmware. Oh, sorry, no, this isn't even. Ah, right. We didn't put this in all firmware. We put this in. We put this in a separate. We copied it separately, which is in retrospect kind of dumb because it doesn't make a lot of sense, and we might as well. Well, they are compressed anyway. Um, so this needs to change. Well, I mean, if it's a path, we might as well just copy the kernels there and deal with it that way. But yeah. So let's just copy the raw kernel, which is what would end up there is these, right? Yeah. Okay, this is a bit awkward, but fine. And then, so the next thing is the image 4 support. These are ASN1 files, and I bet the compressed ones have a different something. Oh, okay, that doesn't work. It needs there. Hopefully that works. Yes. So what we have in this case is a sequence, and then inside that we have an IF5 string image 4P, a tag which whatever. Oh, and this is apparently an yeah, the like build host or something. And then that's just the compressed file. So yeah, it's just there's no tag for that then. It's just an octet string. So I guess we just have to assume it's compressed because it should be. Install radius for subholding FDE, recovery partition. Yeah, I mean, I think that makes sense. I've thought of that kind of approach. Kind of the tricky thing is going to be figuring out how to make it not take up too much space, or make it easier to kill, like have the partition at the end or something. I don't know. Yeah, but yeah, something like that makes sense. Stuff for the future, though. First, we have to get the hardware working. Okay, so kernel. Let's look at some of the other stuff. For now, we can make sure I get the multi-touch, and I can just steal some of that. Let's just do a kernel firmware collection. We load from source path. But in this case, it's not firmware anyway. So when you do the update, we would want to... Yeah, that just goes to firmware Bluetooth. So this is the kernel firmware collection. Let's just say it's in temp here. I'll have to fix the script so it actually copies them there, but that's fine. Add files, sorted call files. I think we only copy the current kernel anyway, so we'll have to support whatever is in there. So in kernel, we skip that list there. If name starts with kernel cache. And then we just grab that. Actually, just the current path here. So now I need an im4p extract. Kernel. Kern path. Read that. im4p extract. And what was it? BVX2? BVX2, yes. And so now, also here at the top, let's get some headers. Might as well get some logs. Okay, so we grab that, and then in here in as media, definitely don't need any of this element stuff. And struct we might use. I don't think anything else. Logging, yes, and we need those. And then I can just have a function here that is so then looking at that again, what do we have at the top on that? 2214A RCFG. Was that a thing in Python that did extractor? Yeah, subsection not found. Okay, so we grab that, and then it would be 2F bytes from that, and then it should be the uh 33. Grab that, and then finally just do grab that, and then we can add a firmware file. And the file name would be what? As media. And these chips, I actually don't know what exact chips they are, because this says 2214A, but I think Uh, we might want to have like some kind of like Apple or something here. Yeah, this is Nike. Yeah, so I don't know if this should be in As Media or in Apple, to be honest. Um, oh yeah, another thing I got. I need to install that. I got one of those cards with the same chip. I need to stick it in a machine or something, but I need to make sure that the changes don't break like the regular As Media cards. Um, so, but for now, it's probably better to just check for Apple platforms. What did the Mac Mini have though? Those ports work fine. Those have firmware. Is it the same controller or a different one? I think it was a different one, but I'm not sure. I need to test that too. Anyway, files, firmware files. Wait, what? How did that end up down there? So then I need to compress it, and then I can just say dot as media import extract as media. And now we need to uncompress it. So thankfully that's pretty easy with this particular framework as the FSC. Linux. Let's just say that and then yeah, it's pretty simple. We don't know the destination size though, which is not great. Unless the header tells us that, which I bet it does. BVX2, B1ED00, that doesn't look like a kernel size. That looks too big. That doesn't look right. The size has to be somewhere, unless it's at the end. Okay, there's stuff after that. How big is the uncompressed kernel? This was 12.3. I'm looking at Mac 13G. What am I doing? Compressed is 17 something. Uncompressed is size 604,000. Is that a thing somewhere? 901. Oh, there you go. Yeah, that's the uncompressed length. It's right there. Do the other things have the same? Maybe the O1 is the compression method. Let me look at the FUD. Like these input device ones or multi-touch. One I care about is. Oh, yeah, these wouldn't have multi-touch because these are from the That's fine though. I can just look at this one. Oh, that doesn't there. Okay, interesting. Interesting. So then I probably want I'm probably going to move like the compression code here then. And for compressed, take that, and then we need to grab another. Then it's another sequence. That's a sequence constructed, and then we have two integers. And then we have tag type, I guess. So let's see type. And tag should be numbers. Integer, I think. Primitive 0. That sounds about right. And then we do raw size. Okay, and now we have the uncompressed size, so we can actually create a buffer like that. Return name, decode LZFSC, cdate. Raw size. And then here, raw size. And we just need to call this one call with C types. I forgot how to use C types. How do you use C types? Make sure that it's And then that one is called label ZFSC. So the ZFSC build. Yep. Okay, and then we need to call that. I think you can just pass whatever for the. Well, xHCI I probably want to actually cast. And it's just destination, source, and a null pointer. So buffer. Yep. So test create string buffer. How do I create an empty one? Yeah, 3 byte buffer, and it tries to null. Yeah, so we just yeah, you can pass bytes, right? I think you can just pass bytes. So this would be raw size. And then the API returns, I'm guessing the amount. Yep. Well, let's just make sure. Let's give it a bit more. No, it should be fine, actually. And then I can just do .lzfc decode buffer test raw size c data length c data, and then I need a null on that. Oh, none. It's just none. Okay. So decoder equals raw size. And then for the string buffer, C types array of type C car. It's just P raw, right? Yeah, it's just P raw. That should do it. I bet the macOS API is going to be a lot more annoying. Chances that it works on the first try, 0. Let's see. Where am I? Where am I? Asahi git Asahi installer. Firmware update. Oh, first of all, apparently I can't even write Python. Okay, source would be Asahi vendor firmware, all firmware. .tar and manifest txt. Kernel firmware collection from update, yes. From kernel. Let's try that. Logging is not defined. In wait, not there. Where am I? As media. And instruct also. Could not find kernel cache. Why? I thought I put it there. It's right there. Oh, is it because no, list their source path. Why? Oh no, because it looks for all firmware tar.gz and then extracts it, and so it's not temp there what I want. It's actually source. Or not. Yeah, so that's not even temp there at that point. And the kernel caches are there. Oh, break. Okay, image 4p extract compressed. A search and error. Okay, what's going on there? Oh, wait, no, because this is already... Okay, so it did work. I forgot. I forgot that, as I always do. Unsupported format string passed... Oh. That. Cannot unpack non-iterable firmware file. Did I forget how that works? Oh yeah, it's file name firmware. Oh yeah, I don't know why I have to do that twice, but is it name instead of file name? That looks like it worked. That's media. Oh, it was easier than I expected. Yeah, that looks like the right blob. It ends at the right place. Wait, was it really there where the... Uh... 7588? Yeah, it is. Okay, and then 8250. Yeah, it's right. It's right. Okay, that looks right. um... Yeah. Okay, so time to test this with funny kernel. Do I want to just implement this in the kernel already? No, I want to mess around with Mini first a little bit to understand that interface. So let's look at that thing. We'll pull that later. For now, Mini proxy client. I didn't even know what Linux version I have now here. It's Asahi whip. Oh yeah, that's like the 6.0 whip, whatever. I think that boots fine. Ah. Let's forget. This is cross-compiling. I don't know if that's because it's... Do I want to use Asahi for this? No, because I already have the biz branches done. So that's going to take a while to compile. But I think whatever kernel is currently there is probably going to work anyway. So let's... we can do the run guest kernel thing. I don't know if that's the right root partition, but I guess we're going to find out. It should be, because I only have a single install on this one. Okay, let's... How did I bug that? Oh, if there's no init ramfs. Haha, interesting. I didn't know that was... Huh. Okay. Why is there even a shift there? Nothing else is using... Oh, it's so that the arguments can be passed. Hmm. Ah. Oh, interesting. Unrecognized arguments? Oh, shift 2 there. Okay, that boots fine. Yeah, and it's actually booting the thing, but I don't actually want it to do that. I wanted to actually just get an init manifest. With... Yeah, that. And then I don't need root. Just test it with that. What, that again? Oh, this would be 1 at that point. That's why. Okay, did the link up? Yes, it did. There's no PCI. Yeah, so it does get that. I think it's supposed to complain later. Unless I wasn't compiling xHCI PCI for that reason yet. No, I do, because the mini needs that. Oh, I might not. Hmm? That's weird. I thought I had that. Maybe I didn't have it in this kernel for some reason. Oh, well, it finished compiling, so that's good. No, xHCI PCI is in there. Oh, yeah, there is an xHCI for... Wait, 4? Did this have 5 ports? Oh, no, because the hypervisor it has 6 ports, and then the one is eaten away. So then why isn't there... Oh, no, it is there. Yeah, it is there. PCI... Hold on. Yeah, it claims to have found it. I thought this would time out after a while, though. But it looks like it's not doing that. Maybe it was different on the iMacs. Yeah. So let's try tracing that. But now, because this is Linux, this is going to be on bus 3. So trace as media. I'm just going to put a 3 there for now. Yeah. That. Ooh. That didn't work. Reads F, writes 4, and then writes 1 to... Yeah, so that doesn't work. Why didn't I thought I had a check for that. PCIe. Oh, yeah, because that would be also a separate state. Any of those is bad. Oh yeah, it gave up like rather quickly. Oh, interesting. There's like let's see what happened. Yeah, so it does a bunch of stuff. That doesn't look right. No, it does. Yeah, those are the config space. Yeah, and then it maps it at C3 bars? Did they get the wrong device? I might have the wrong device. That doesn't look right. 1D6. No, that's the wrong. This is the wrong device. Oh yeah, this is what I was expecting. Board failed to stop command ring. Why didn't that happen before? Um. Oh, it's at 4 now. Did I just get that wrong? Hey, Dreamer. Good evening. Yeah, there you go. That's that. Yeah, now it's spamming that, which is when it tries to reset it. And also means that now my scroll back is completely gone. No, it's not. Yeah, so it so reset does work, but it's it's setting it to operational that doesn't work. 38 is command ring control. And it's looking for command ring running. No, that is running. I think it's because it's doing a reset now. Hold on. So it does reset works. Then it does a bunch of stuff. It writes 3C to 0. That's reserved? Oh no, 1C. Sorry. No, still. Wait. Huh? 64 bits. Oh, the pointer height. Yeah. And it writes a command abort. Status. Oh, there's xHCI reg map in Mini already? Yeah, so it should stop the command ring. And that's what doesn't work. It's waiting for the command ring to be stopped. Yeah. Yeah, base is at 20. So yeah, okay. This is what happens when it doesn't have firmware. By the way, the ports work. Like, oh right, that's why. Because I have something plugged in now. That's why it broke. Like, I think it tries to initialize when you plug something in, and so like the port interrupts do work or something. But then yeah, I think it's something like that. Anyway, this is fine. And now the trick is going to be loading the firmware. So let's see first. Let's add some tracers while I'm here. Mon.add xHCI registers. Let's look at the top of that, and then the config space. Actually, let's look at everything here because it's got a lot of stuff. And then config space is where that. Is that right? I think so, yeah. And the ones we are interested in are starting at, was it C0 or something? E0. So let me just add those, see what happens with that. Okay. Interesting, there's something changing there, whatever that is. Give me 1 sec, I'll be right back, and then we're going to manually trace through the init sequence and see if it makes sense. Back, and I just saw that Jano mentioned the Mac Mini has Fresco logic, xHCI. Yeah, that's right, it was Fresco. Which is why it doesn't need firmware. So let's look at this. That's going to be annoying. Let's not trace. That's 308. I don't think we had that anywhere. We had 9. So I guess it is relevant then. Yeah. Oh well. Yeah, I wonder what that is. Okay, so let's do a little experiment here. First, what's up with these? Actually, yeah. Let's just look at this for now. See what's up with these. So we read E0, that is 0. And you write to F8. Whatever that is. That shows up at F8. And we write 80 to FC. Shows up there. That's fair. And then we write 1 to E0. That doesn't do anything. Sorry, what? 2 to E0. Still doesn't do anything. Oh, sorry. Yeah. Then we read it. It's still 0. Then we write 4 to F8 and FC. Then we write down the 2. Still nothing. And it should show up in F0 and F4. That's not working. Why? That's already not doing what I expected it to do. So it has to do with command. Is there a magic thing about this? Also, what about the other space? 11:20. Yeah, that's correct. So this is doing is it enables memory space. Well, that should be enabled. Command register is offset 4. Yeah, and that is enabled. Everything's enabled. So I don't really understand why, like, let's clear the monitor, try doing that manually again. So I did mess up a little bit, but I'm not sure if that's the problem. So we read 8. Write 32. Let me write 1. And reading that back should return 0. Then we write zeros. Write another 2. And then reading that, still 0. Okay, so something is different. Huh. I don't know if that's necessary though, that part for things to actually work. And then there's this other stuff, right? Write 2 to that to 3000. That is a 2, and then we write 1 to 4. Then write 5042. Read 9, write 4, read 9. Then we read 20. That's 7 now. It was supposed to be a reset. I think it might just be confused because it got initialized without the firmware and maybe some stuff is locked. So maybe I need to actually reset it the normal way first. Ah. Okay, that's the reset. And now it's stuck on a reset. Let me just copy and paste some of this stuff. Make it a bit easier. 5040, 5042. Let's make it K-write. It's a bit easier. And then we read that. Still stuck at 2. Oh, that E0 stuff from before. Yeah, still all zeros. Looks like it's just dead. Maybe it's just that, like, if you try to use it without the firmware, it just, like, locks up. Yeah, maybe it just locked up. Let me try the other mon part just to see if there's anything interesting happening there.
Oh, the thing about blinking isn't blinking anymore. That's interesting. That could be a port status thing. Interesting. So 308 is changing from 2 to 3. And then some other stuff changes. But not 8. Oh, wait, it's write 16, not write 32. I don't know if that matters, but it might. No. I might need to reboot this. And then maybe just see if it works doing it from Linux. This is clearly not working doing it from here. So either way, Linux is compiled, so it should be easy. Drivers, USB, host, xHCI, PCI, and then the rancid stuff is, I think, what we need for that. So I'm gonna have to create one more of those because this is the same story, I think. Yeah, firmware download image. You know, this data low, data high thing kind of looks similar. Now I'm wondering. This looks the same. Not the same, but it looks related. Well, it's not EEPROM flashing because there's no EEPROM here. This is just RAM. And then there's this driver data firmware thing. Is that because it's only used for embedded devices? It might be. And then we can just define it in the device tree and only load it if it's set there. That actually makes sense. That's probably what we should do for this particular case. PCI, yes. Yeah, it's in there. RenSS firmware quirk. So we need the kconfig and the make file. As media. Depends on RenSS. What sense does that make? Why is there depends on one, or that doesn't make any sense. Why is this tri-state? What's going on here? That doesn't make any sense. How this is like that shouldn't be a module. Is that a module? Oh, it is a module. Ew. Okay. Why? That doesn't make any sense. Why is this a module if that doesn't make any sense. If it's you're just adding a dependency that is always going to be there because it uses a symbol from that. That doesn't make any sense. Who wrote this? This is like this doesn't make any sense. You just do that. And then what you do is that. Git move it. How was that done for modules? That's how you do it. Well, mini already didn't work, so I'm just going to try it with Linux. But I just realized that the way Linux handles an existing USB controller with firmware makes absolutely no sense whatsoever. So we're fixing that. Apparently, Linaro wrote this. um, the Renaissance one, by the way, was that was N. Let's save that. Yeah, that compiles. And then as media, xHCI, check request firmware. It's a PCI dev. And then I can steal some of that scaffolding. Firmware module, no module. There is no module here anymore. And so here in as media, I guess I'm just going to guess some of what these things mean because I have no idea. So the sequence here starts like that. And then we end up with that and the SRAM writes. And I know what the pattern is. And there's the readbacks, which we are not going to do. And then finally, that happens. EF gets set to 0, another reset. Then a write, apparently. Then, for some reason, the PCI stuff is getting changed, some commands there, but I don't think this is relevant. And then the regular PCI driver should take over everything. There's a 0 there. Okay, so that's basically the sequence that we want. We are going to make up some names for these things. Those are the 2 bits we know. And then we have as media. write data low is F8, write data high is FC. And then read data low and read data high would be F0 and F4-ish, probably. There's something at E0. SRAM access. And then the SRAM address was where? Where am I? That's E2. Okay. And then the MMIO ones are like that. I'm just going to say that's command or something. I don't know what that is. E0. That's it, I think. Bar 0 registers. And then, yeah, again, we don't know what's going on here, but let's say reg command is 3000. 9 looks like some kind of status. And 4 is like... Well, that looks like 0 is command value, and then 4 is something else. Or maybe it's just argument. Just guessing here. But it always writes 1, so it's like... Then it's reading something. Oh, it's just the data. Sorry, that's just the data getting checked. Yeah, don't need that. Yeah, something like that. Okay. As media, xHCI request firmware. Get the core file out. Renesys data. Whoever wrote this was not very good at not making typos. Then that quirk is... where's the quirks? PCI quirks. Is it this one? No. Why is this not even in, like, why is it a separate file anyway? I don't. Oh, this is not. This is for xHCI and stuff. xHCI. Where's the quirks? It's just an xHCI.h. Okay. It's media firmware quirk. Actually, how do Linux patches work when you rename a file? Hopefully, it's not like a whole file, like minus plus in the mailing list. Okay, so probe, yeah. As media firmware quirk. And also that should just move here at that point, because it doesn't make any sense elsewhere. So the device ID here is what? That one. What did I call that file? Let's also just add it. We'll just try this everything in firmware. Init ramfs firmware lib firmware. Actually, just untar that. Yeah. Asahi installer, and I think it's that. Yeah, S media 2214A Apple. I'll call that under as media. Well, we'll shave that yak later, but for now, let's do it like that. And then I have to figure out how to determine whether it needs this firmware or not. Like, I need to plug in that card I bought with another chip and see if I can test for it. As Media is the brand of the USB chip that's in the Mac Studio on the iMac. And Apple decided to not put a flash on it, so it's the only one on the market that doesn't have firmware, and so we have to load it. Okay. Where am I? Here. Isn't different for a Apple. Yeah, we'll shave firmware name Mac later. But for now, okay. As media, check request firmware name, driver data firmware. Yeah, we'll follow that. This media check ROM. We don't have that yet, but this is to do. Get rid of that. Yeah, if it yeah, we don't know how to check that yet. Let's just get rid of that. Firmware request, no warn. No, I do want to warn this time around. If it's not there, we definitely going to find out. If error. Yeah. Complain. What does verify do? There's actually a documentation for that. Yeah, well, not useful here. As media, load firmware. pdev firmware. Okay. So I guess this is literally flashing the firmware if it has a ROM. And then if it doesn't, it just does it like in RAM, which is interesting. But that's not the case here. So yeah, I think that's because like these chips were never intended to have host supplied ROMs. But like Apple likes not having firmware chips, and so they're using this kind of horrible debug thing. You know, I think there's actually there are actually firmware updaters. I wonder if there's any strings there that we can find, because I know the Apple driver doesn't really have any interesting strings, but that's 1142, but it might be similar. And maybe we can find some strings there. So let me do a quick test for that. Actually, what is that called? Vmax. What is that? What is that? Okay. Right, PCI, yeah, lovely. So it's doing all the raw stuff from user space. Excellent. ASMIO.dll, I bet this is like a backdoor driver that lets it just do everything from user space, because, you know, that's how it's media roll. Okay, so read mem, write mem, registers. Okay, is there gonna be something for... Yeah, so this supports flashing all that stuff. Okay, but let's see if we have some strings that tell us something. Insert config to bin. Interesting. Transcend. Lots of random checks there.
Okay, there's some register names here. Battery charge address? No, that didn't look that useful. Anything at the top? Oh, this is just outright the firmware, right? Yeah. And then the firmware update comes on. So this is 2.1.4a firmware. What was that called? No, it wasn't 2.1.4a, was it? Oh, it was, yeah. So it is the same story. Yeah, I'm not seeing any interesting register names. You can just like map MMIO with this. That's great. This driver is amazing. Um, yeah, I don't think there's anything interesting there, unfortunately. I wonder if there's any other versions that are interesting. I love these Russian sites. Oh, there's a Dell one too. Oh, that's the one I got. There's a Dropbox. Yeah, of course. And people talking about macOS too. So all these dodgy sites.
Okay, whatever. This is make it work. Doesn't look like it's anything interesting there. So there's check running is not a thing we have. There's no ROM erase, no setup ROM. As media firmware download. Should just be this, to be honest. We're not going to verify anything. We're not going to download. Yeah, okay. So I'm just going to copy and paste the relevant functions that we care about. Okay, so the sequence is... How do we do config space writes? PCIe read config byte, blah, blah, blah. Okay. And then write config word. Yeah, so that's the basic functions we need. So I don't know what those reads expect, to be honest. Let's not make a loop. I don't know what's necessary there, and just see what happens with that. So we do read config byte. Command. Read config byte. And we just need to be... Yeah. Really? We need that? Do we really need that in everywhere? That sounds kind of wrong, but... Do we really need that? That doesn't look right. Actually, nothing's really checking return values for this, to be honest. Yeah, nothing checks return values for PCI config bytes, which makes sense because like most of the time you can't check return values. It's like a memory op, right? Yeah, pretty much nothing checks that. So we're not going to. Okay, so what? Let's do some prints here. CMD, print that again. I'll simplify later, see how it works, but for now, it's just duplicate everything. We write config word dev, and this is called config command. Then we write data low. High, put an 80 there. Byte, CMD,
2, and then we read it twice again. Then we write more of that. And this time it's zeros. And then you write another 2. It should be getting 3s the second time, third time around. And then we should read the data. Data L and H. And then we write a 1. Should be getting 3s again. And then we can read, I don't know why it's reading byte-wise, but let's just read it indoors and hopefully that works. And then we write a 1. Command 1, yeah. And then there's the other stuff. Let's see so far if this actually works. We can kill it after that. Actually, no, that's fine. Okay, let's just see if that compiles and runs. Where am I here? Firmware request. Why? Is it the no error thing? Oh, it's request firmware, that's why. Okay, dev undeclared pdev. I guess that is pdev. Okay. xHCI check request. What? Why is this media.c? Oh, because it, yeah. That should be inline. That's another bug. Okay, let's see if that runs. That doesn't look like it did it.
That doesn't look like it actually worked. Something didn't work. I haven't actually compiled the firmware in yet either into the init.rmfs, but yeah, it does have. Okay, yeah, the firmware because yeah, okay, sorry. Yes, it's because the firmware isn't there. So in here, yes, that's media, blah blah blah, Apple. And then it was the CPIO dash. Yes, that. And then that. And that should make it work now. Yep, there we go. That's the sequence. Oh, and it does actually match what Apple did. So it does work if you do it like at the beginning. So one thing I want to do is understand what this is doing. So now it failed anyway. So in theory, I can mess with Mini now and it won't actually be broken. So if I do the sequences now, hopefully this actually works. If I add that, oh, yeah, just add that. And so now if I do this, that's 0 now. If I write, those get written. If I write that one, nothing happens. And then still nothing. Uh,
Okay, let's try some more extra reads in here. I wonder if the mon is the problem. Okay, so what happened now is read zeros, writes to read zeros, writes to reads threes, reads that, still 3, then writes the one, still 3, then reads those, writes the one that becomes 0. I forgot to read there. That's the important one in here. And then what I'm going to do actually is call this twice, because I want to see what happens if I do the whole thing twice. Because I suspect this might be like a get firmware version sequence or something like that. Or maybe get some kind of status. Okay, 0, 3, 3, 0. Yeah, it does work twice. You get the same data back. So why doesn't it work when I do it from here? Is it because I'm too slow, or because I'm doing something wrong? Oh, now it works. Now I got a 3. Oh. It's read sensitive. Or does that just mean that the... I am getting the feeling this is a FIFO, though. So then I need to read 32 F0 F4, and I'm going to do it twice. Yeah, so you get the same thing. Still 1. And then you write 1. And then you get a 0. Oh. But then the reply never came. Maybe there's a timeout? Just paste everything at once. Okay, now it works. So I said because it timed out? I feel like there's some kind of timeout involved. Yeah, look at that. Yeah. So if you don't do it fast enough, it doesn't work. So this isn't a FIFO, it's a mailbox. Yeah, so it's like there's a timeout on you getting one half of it so that the other side can fill it, and then if it times out, it just gives up on that. And then it has read your... I guess that's kind of dummy data, but... Yep. See, this is how you divine what registers mean without really knowing, just kind of pattern match things that make sense. So in this case, it's not command, it's more like mailbox status. I don't know why SRAM address. Yeah, well, that's fine. But then xh xl inbox dxh, and then here we have status tx is 2. What is the data we get? 5,000. Yeah, I don't know what that is, but it looks like a version really. Okay, so mailbox transmit. What we do is we read, and we need some timeout. Is there a thing for that on Linux already? It sounds like it should be. Maybe not. Okay, time is a timeout thing. Let's dig it in microseconds. Okay, so we read status do or rest of error. Okay, something like that. If cmd and set this tx. If not that, break. Actually, I mean more like at the time I'll just check for that. And then we write the two doors. But in this case, we call these TXL and TXH. Low, high, return 0. And then we write the 2. And then mailbox receive. We wait for data. Invert the logic here. Joey, I will kill you. Also, this is not C++ or Rust. Okay. Box tx dev do that. So we transmit that. We transmit zeros. And we're supposed to get the same data there, so don't know what the command actually means, so I'm just going to print that. But this will be useful when we get to doing it with the cards that do have firmware. So let's actually build that, and just should still work the same way if I didn't typo things, which of course I did. It's pdev, I guess. Not now. Dev undeclared, didn't I? Oh, pdev. Config inbox status is what that's called. Now. Actually, more like inbox command, really. Inbox op. Let's make it a bit shorter. It's one too long. Oh, and op. Okay, there we go. Too many arguments for format. Oh, right, that doesn't need that. Integer from pointer, that's not right. Write config word. Oh, read. And then I can actually just do it once. I don't care if I do it twice this time around, just to see what happens. Oh. What? Oh, I guess the kernel was incomplete, and it like concatenated an incomplete kernel. Let's see. Yep, there we go. Yeah, that worked, looks like. Yeah, we got the data. Whatever that means. It's the same thing we got with the hypervisor, right? I don't even know where I am anymore. That's media. 59,816. Yep, and then it's 1, 2. I wonder if that 6 there is the length of the reply. That would kind of make sense. Is this anything 8216? 2070? Nah. The interesting thing would be calling this function again after the firmware is loaded and seeing if we get something different. Also, did this ever mention anything interesting, like in the logs there? Oh, look, firmware version. So it is the version. 090816. Yeah, okay. Let's media get firmware version. Let's just do 64 bits for this. And then I can low, high, read it like that, and do that's just because the firmware would be inverted from the file when loaded. So I think that means that the config words are in the proper Indian already. So we shouldn't need to Indian swap. Not that anyone's ever going to use this on a big Indian machine, but yeah, that's fine. Something like that. And then that should be called from check ROM, even though we don't have that yet, but we should. This guy check firmware. If return and I guess we might as well check for that one, and we'll see what the real cards have. Okay, so now load firmware. Now is the fun part. Now we need to mix MMIO and config space, right? So we have the sequence was, where is this? In here? No. In here. We've done this. I covered that. Access read. I'll typo that. And then what is that? Access enable bit 7. That almost looks like another mailbox. Let's see what happens if I just write to it now, like after that started probing. Let's do the rest of the sequence. So we do this. Let me add them on. Yeah, stuff's happening there. So now if I do these one by one, let's see what happened there. So we write that, it just gets written. Then we write that command that actually does get written. Then we write some other command. Interesting. So the second time we write that, that doesn't change. But then that 20 became 2, and now it's still 2. So it's still resetting. So that's not working then. And then at 3000, at 08, where was my log? She doesn't touch. See, now it's stuck. Maybe it is the mon. So as soon as that command got written, the 2 there got set. And that was already set at 9, though. And the second command, that got cleared. And then when that 2 got written, that initiated the reset. Is it like forcing a write of that register? No. Let's reboot. And let's actually put it in Linux and see if Linux does the right thing. Maybe there's timing involved again or something. Oh, whoa, 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 whoa. I got the wrong right there. That's why. That's why. Okay, so it's 2, 1, and then 1, and then there's like 3 and 0 involved. So let's add that to the mon, and then that didn't work. Okay. Okay, that did work. That did reset. So let's see exactly what changed. Right, it's 5040. That does set bit at 8. Checks for the 2 there. Then writing at 3004 is just sets that. Then it writes 42. And then when it writes 3004, so it writes the one there. It looks like that's just random register that gets written, but when written, things happen. Yeah, so I don't really know what the read nines are for. Like, what are we expecting there? There's also the 3, and it's up there at some point. Yeah, that just sticks. Oh, interesting. And then, okay, one does let it reset. So one looks like reset or something like that. And 2 is, I don't know, maybe like halt. So this looks like some kind of control register. Yeah. Oh wait, it's 8 bits anyway, but yeah. So it looks like one is reset, and 2 is halt. Just to check exactly what that was. It's supposed to be the reset. Yeah. Yeah. So 2 like keeps it in reset. So what this ended up doing is and then what about that 9 thing there? Yeah, so 2 puts it in reset, 0 lets it come back, and then 1 is like explicitly reset and come back. And then the 9 thing there. It's always 2 right now. And it becomes one with a 5000E, but only... Only after this gets written with 0. It goes from 3 to 0. In this case, it's still 2. So maybe it's like a firmware status or something like that. So what about that 5000E thing? Oh, that makes it 0. No, that makes the bottom one 0. Yeah, that's it. Yeah, so I'm guessing 9 is like firmware status or something. Okay, let's give that. Let's go with those names. So this one is some kind of control register. This one is reset, and let's call that firmware status. And then reset once is bit 0. Reset hold is bit 1. I'm gonna go with those names. Which means the load firmware operation would be first, we don't know what these control register values mean, and I'm not sure we're going to find out very easily. So first we need to map bar 0 here somewhere. How do we do that in... so... where is the... What is a probe to get the registers? Oh, USB HDD PCI probe is what does that. Yeah, sure. It's not even there. It's in core. Do I want to... Do I want to do this in a different function, not all the way back here, but more like... PCI probe. Maybe you can just do it after this. But where is that stored? The HCD regs, and HCD is... Yeah, it's just driver data. Okay. Where's the quirks get set? xHCI gen setup. Called during probe after chip reset complete. So yeah, this is not after chip reset. So if I can do that like after the probe, then I get the registers already, which is nice. Let's try that flow. Low, where did I get low there? It's not low anymore, it's data. Oh, it is low. Ah, data. 64 data. Okay, let's try that. As long as that happens before the chip reset, I'm good. Ooh, okay. That didn't quite work. So setup gets called before the reset. So maybe that's where that should happen. maybe I can just look at the quirks here. What does gen setup do? Okay, it reads the caps. That's okay. Oh, but then it starts doing halts and stuff. We don't want that. Unless we do it in get quirks. That's not actually useful. So we should just do it before this. Yeah, because it's a bit easier if I just don't rematch here. So then, what if I just stick it in here for now? I mean, it's not exactly right, but it's actually a good place to have it. And then I can just do this. Oh, but there's no return values here, so we can't return a failure. So that doesn't really work. Okay, then let's just... I guess we can just put it here for now. I need to get driver data then. It's pdev. And then in this case, it's just return red file. ID driver data. That needs a cast, right? Yeah. Okay, let's go with that. So I think that should be fine as far as the order of operations is. So now in the actual, let's do the loading. So I need to get the registers for this. I can get, I think, driver data for it. There. Gen setup, xHCI, HD cap regs, HCD regs. Yes, so I can get that. Then the driver data is set here, I think. Yeah, HCD. Why do we teach Linux about firmware loading? Come to just do it from Mini? No, because Mini doesn't know about PCI, and in fact, it doesn't even turn on PCI devices. And also, Mini can't access the firmware because where would they get it from? Okay, so regs, it should be just xcd regs. That's IOMEM. Right, that's the reg thing that really kills my like token thing. That'll take a second. Too many things start with reg in the Linux kernel. Uh, is it right? H relaxed? Right, W relaxed? Yeah. The register there, and then I don't know what we expect from that 9 register though. So, because I've never seen it like something else. Come on, you can do it. $42, and then it's a 1. Then we check and we do 5000E and 401. I don't know why we would. Oh, it's another. That triggers another reset, but I'm not sure why we would do that. I'm not actually sure if that makes sense. 1 sec, I'll be right back. Okay, well, I was going to recover it, so that's good. It's CD regs. So then we have right W relaxed regs plus. Let's put this in here. So then what we have is a hold. And this is right B, I think. Yeah. Right, and then I need the poll thing, which I think this uses, yes, readable poll timeout. Not atomic here, though. So what I actually want to do is check for the halted. That is that, right? No, reset. Where is the reset thing? Is this exported anywhere? It looks like it. But it's not it's not actually exported though, so that's not useful. I guess we just do it ourselves. So let's go as media weight reset. I can just pass it an HCD at that point. And then it would just be that again. I did it again. It really doesn't like that. There. Okay. It's just HCD regs for some reason. Like this is the regs thing. It's fine. It's like as a struct members when it really gets weird. Yeah, it's not running. I'll just read the. I need to look for xHCI uprex command. Yeah, but then that's like. So maybe we can just do it like that. Yeah, I can probably just kind of steal this code. Of course, Tegra uses a Falcon for USB. So basically, just grab the cap regs, grab the up regs. There we go. And then this is doing up. Oh, I can just do HC to xHCI and use the up regs. I think that's already set up at that point. When does that get set up? Gen setup. Oh no, then we don't have that yet. So then we do have to do that. And then the reset. Well, it is register 0, so I can just. Oh, it is HCI up reg. Sorry, yeah. So then I can just say up command. Where was that? Yeah. Results. I don't think we need atomic for that. Result. Not result and command reset. Let's just go to val. And then, but actually for the reset timeout usec, let's make it a bit longer. As media weight reset. Let's try that. Then what does read poll atomic actually return? Read poll timeout. There. Address the poll variable, the poll condition invalid CPUS. We can go to that. Give it longer than that. Return 0 on success anytime dead on timeout. Okay. So it's just a regular return. Let's see, wait, reset, HCD, if ret, return ret. Actually, how do I get the dev out of an HCD? There's gotta be a pointer for that. Yeah, HCD self controller, I guess. Do I have xHCI? Yeah, I do have xHCI.h here, but that's not exactly what I want. What's xHCI to HCD? Oh, xHCI debug, yeah, okay. Okay, so then I can just use that. Okay. Let's media wait reset. Let's see turn that. Okay, and then we continue with the sequence, which is 5E and 1. So another reset apparently. I don't know why. And then we do the SRAM access thing, which is this one, EF. And that's config byte. Access enable. And then we have to loop and get the firmware copied. Okay, so address val Well, address is less than firmware. How is that? Size or something? Yes, firmware size. And the data is just firmware data. Our address is less than firmware size. Then address increments by 2, but if address and 8000, because we're copying in
in blocks like that. It would be like that. I don't think that's actually correct. It's reading from the firmware without doing but actually, if these write word and stuff would be using CPU endianness, so if we are on the wrong endian machine, then it's still going to work fine as long as the firmware has the same endianness. So I think we're good. Oh, actually, this would be let's just say words. Address is less than words. And then it would be like that. Something like that. And from our data, and then that has to go first the address, config word, pdev, sram address, and that is actually like shifted. And then we write the sram data. Let's call it data. Data to reg sysmedia reg sram there data. Okay, and I'm not going to bother with the other stuff. I'm just going to do the rest of that. So that then gets 40 and 5e. M5000E and a 0. I don't really know why it writes both bits in this case, but and then we wait reset, and I think that's it. And then the normal stuff happens. Let's see if that works. Let's see if it compiles first. Read out poll timeout. All right, that's Linux IO, I think. And then xHCI, it's not upright, it's just up. IO poll, is it? And then there's a ret that we're missing somewhere. Yep. And there's no exit here needed. And has-rom is not a thing anymore. Ret undeclared. And just for consistency, let's call this one ret 2. What? Wait, reset? What did I do? Oh. Okay, dev what? There. And then might as well also print that here. Firmware upload failed. Oh, and then no return red there because we do want to use the firmware. Let's see if it works. And if it works, it's time for me to get some dinner. Ooh, that didn't work. That did not work. Why? Oh, it's actually testing the reset thing before anything happens. That's not good. Are we like not calling this at all now? This is after chip reset completes, so I think we might be. too late here. It does call as media setup before twice even. Because of the companion controller. But why doesn't it actually do it? Oh, Renaissance. Wait, no. Otherwise, I'll move it to the Renaissance thing and do my own like IO request thing. It does call from a request. I I'm confused. Is the I'm confused. Why is it not calling my code? What am I doing wrong? It does get there, and then request firmware. If red equals 1, return 0, and check firmware. Actually, dev info here, but why isn't it even getting that far? Everything here is checking stuff properly. What? Kind of confused. What dumb thing am I doing? It gets here. It gets to check firmware and then get firmware version. But the thing is, like, all the code paths here are already TXXRX, and then that's the EIO. Oh, come on. Hold on. That's the problem. I don't return the data. I return 0. It's just version at that point. Okay, now it's gonna work. Aha! That's a firmware load. The interesting thing is it's going to call it twice, and I'm hoping the second version is going to get a different firmware version and not call it. Oh, wait, no, it shouldn't. Not this time around, I think. But we'll see. Ooh, oh, no, that's normal. It's just... Wait, no. Null pointer DRF? Interesting. What did I get wrong here? Oh, words. And I'm also not going to trace it anymore. See what happens. Firmware upload failed. Reset timed out. Maybe it's just slower. Let's give it a whole second. I do have the arguments to that, right, don't I? Delay timeout. Nope, I think it's still timed out. Maybe I do have to read that other register in between stuff. Oh, yeah, no, it is Word. Oh, I forgot to undo that. That's the problem. And it has to happen in between these, apparently. That would explain why it doesn't reset. Probably. Probably also doesn't need 100 milliseconds. But it might as well do 1 second for now. Okay. Still reset timed out. Let's trace it. Oh, wait. That doesn't make sense. It loops back. I missed something. This increments. No, something is wrong here. Something is not quite right. What? They don't emulate any subsystems. Rosetta doesn't use any subsystems. What are you guys talking about? There's no drivers involved. Why does it wrap? That's not right. Oh, because it should. Right. Because that. Right. I need to There's no libraries to emulate. Rosetta is just a standalone Linux binary. You just have to like patch a stupid check. There's no like there's nothing to emulate. It's just a stupid like anti-piracy check. And bypassing it is breaking Apple's license, so please don't do that. There's no Mach binaries involved. It's a Linux binary. You can just like LD preload something, or or use htrace or whatever to like make it skip the check. There's no. It's a Linux binary. Rosetta on Linux on VMs on macOS is just a Linux binary. No, Rosetta is ELF. It's just a Linux thing. Like literally, they just shipped Rosetta for Linux as a Linux app. There's like nothing macOS about Rosetta that they ship for Linux. It's a native Linux Rosetta. The only thing is it has a stupid DRM check to check that you're running it in a VM under macOS, and they just bypass that. That's it. Okay, there we go. That still didn't work. No, yes, it did. Hey, 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 it works. That Ethernet thing is the one that plugged into the xHCI ports. It works. Yep, it totally works. Okay, let's try it again without the tracer. And I don't think we need that much of a timeout. We can probably be a bit less loopy on that. Because we know it's kind of slow. Yeah, look at that. See, the firmware version gets, like, upgraded a lot. So that kind of makes sense. So in that case, let's actually add a define for that. Yeah, so it does run it twice, but that's okay. For now. The only silly thing is that ideally we wouldn't do that anyway. Oh, okay, we want that. Let's check for that. Just check for primary HCD, and then either way, I still want to print the firmware version again. Something like that. Okay. So the only thing left, which I'm not going to do today, is making that uncompressor thing also work on macOS. And then that's it. And then commit and push and all that. Make the ports work for everyone, which will probably come in with the next kernel update anyway when I merge in the new sound stuff and all that. So that'll be a big update in the near future. Does it work on both iMac and Mac Studio? I hope so, but I am using the iMac to read your comments right now, so probably not the best idea to test it on the iMac now. But it should. It's the same thing. Oh, what just happened? xHCI run? What? I'm confused. How did I break it now? That doesn't make any sense. Oh, is it because of that? Oh, because oh, maybe we can only check that after its primary HCD. No, but I mean, set up it. I'm confused. How did I break this? This doesn't make any sense. PCI setup. What is that address? It's not supposed to take that long. Try enable MSI? Oh, is it? I think I know what happened. No, I don't. Hold on. What? Yeah, I know what happened. Because read this one there. It's just returning and skipping in it. Really should be it should be that. Just in case. So fix it both places. Okay, that should work. Yep, there it is. So one interesting question is whether it does like Gen 2 and all that. I think I have some stuff that is Gen 2, but I'm not sure. Like some NVMe enclosures and things. I'm not sure I want to pull one out right now. I'll test that later. Anyway, it works. Okay. Can't wait to try this new gun on my MacBook Air. On your MacBook Air? But yeah, it works. We're good. Thanks as always. So yeah, I should get some dinner, and I will push this later. But I'm glad this works, because this also means that I can start using the Mac Studio as my home server, which I've been meaning to do for a while now. I just have to decide what distro I put on it. But that is now unblocked, so that's good. Though I want to use like 3 machines as like multiple home servers, and it's probably going to be one the Mac Studio, then a Mac Mini, and I'm just kind of thinking like I should wait for the M2 Mac Mini, and that way I can just have like the trifecta. But yes, Maz will be happy. So yeah, thanks for coming. Next time we'll be using this PCIe stuff, tracer stuff that I built, to figure out what's going on with the Wi-Fi when on sleep. And also some stuff with AP mode is broken and some other things, and also the Bluetooth coexistence. Basically, I need to make a Wi-Fi tracer, so I'll do that. Hopefully, that works. Um, and yeah, actually, I do need to test this on the iMac because it's Type C ports, and I don't know if that makes something more complicated. But anyway, it probably will work out of the box, even if the mapping of the ports isn't perfect. I'm not sure. So anyway, all right. Thanks for coming, and I will see you next time. Bye.